Section 6.4, Least Common Denominator. In this section, we're going to attempt to rewrite two or more fractions with their LCD, their least common denominator. And obviously, some of these fractions are going to be plain old numbers, which is nice. You guys have done that before. But we're also going to do algebraic ones. There's two big things to note in this section, and keep in mind. If you're going to do anything to the fraction, you must look at the denominators in factored form first. Okay? All denominators must be factored. The other piece is that you can only change a fraction through multiplication or division. And what I mean by that is, for example, this problem. We're going to want to get an LCD in this problem. And a lot of people will say, okay, here's an x plus 2 and here's an x. I can make this x plus 2 by just adding 2 to the top and bottom of the fraction. But this is something that we cannot do. Do not add or subtract to find a common denominator. You must do it through multiplication or division alone. So you ask, if I can't add or subtract to change a fraction, how do I use multiplication to do that? Well, if you look at this example right here, this is my simplified fraction. But I want to write it with the denominator of 10xy. So I'm going to look at what's missing here, that is here, and multiply it by some numbers so I can get this. What I mean by this, I'm going to ignore the numerator for right now. I have a 2 and a 10. What can I multiply 2 by to get 10? 5. I have a y here and a y here. That's fine. I'm not worried about that. It's in both denominators. But what I have here is an x, and there's not an x here. So that means I need to multiply by x as well. So what I'm saying is, if I take this fraction and multiply the denominator by 5x, I will get this denominator. That's great because I can change a fraction by multiplication. But if I do it to the bottom, I need to do it to the top. So it's really telling me that if I multiply this numerator by 5x, I will get 5x squared. And now these fractions are equivalent. This one with the denominator we're looking for. Alright, what can this numerator be? So these two fractions are equivalent. Remember what I said in the beginning of the video, we need to look at all denominators in factored form. So right here I have an issue. I'm going to start by rewriting this. This is the dose rule. Now that I see my denominator in factored form, I can see what factor is missing. This denominator has the x plus 1, as does this one. But in this case, I have an extra x minus 1 being multiplied to it. So if I were to take this denominator, multiply it by x minus 1, I will get this denominator. What I do to the top, I must do to the bottom, which means that right here becomes 2x minus 1. This is the expression I'm looking for. Do not try to resist the urge of canceling these right here. If I cancel these, I'm just left with what's originally here. I'm trying to say if I have this simplified fraction, what does this numerator need to be to get this complexed one equal to it? For the next set of problems in your book, I would refer to page 260. They give a nice little in this nice little gray box here, they explain how to find the least common denominator. Notice first they say factor the denominator completely. Then they say find the product of the greatest power of each factor occurring in the denominator. This is the same way we find LCD with plain old fractions, but in this case sometimes the factors they're talking about right here might be an expression like x minus 2 or 3x plus 1. So let's try to find the LCD between these two fractions. I can ignore the numerators completely. I do not care about the 1 and the 7. But when I look first at the denominators, I check that they're factored. Yes, they are. Then I look at the big numbers, 4 and 16. The greatest common multiple between those two is 16. So that's going to be part of my LCD. Then I look at the variable terms. This has a t and this has a t squared. I need to take the highest power of t, and that's t squared. This one has an r, this one doesn't, but if an r is here, it needs to be in the LCD. So if you look at what I did, I looked at the greatest common multiple between the big numbers, and then took the highest power of every factor that's present in the denominator. Let's try the next one. This one doesn't have just plain numbers and variables. These have expressions, x plus 1 and x minus 2. This x plus 1 is grouped together. If I want to use it in my LCD, I need to use it all together as x plus 1. So ignoring my numerators, check that my denominators are completely factored, and they are. I have an x plus 1 in this denominator. I don't have it here. I need x plus 1 in my LCD. That takes care of this one, but this has an extra factor in it. This has x minus 2. What's really going on in these two fractions is that they have nothing in common in their denominator. The two factors in the denominator have nothing in common. So you multiply them together, and that's your LCD. Let's take a look at this last one. Okay, first thing I'm going to check, I'm going to ignore the numerators and check that the denominators are factored. This one is not. So I need to use the dose rule to factor it. Excuse me, that was my dog. So now I look at what factors are in the denominator that needs to be in my LCD. Both have an m plus 2. I only need to use it once in making my LCD, since they both have it. So this denominator is taken care of, but this denominator still has an extra factor of an m minus 2. This, excuse me, is my LCD. Alright, now for the hard stuff. The last section, starting from 33 to 43, is asking you to rewrite each fraction using the LCD. So that means the first step we need to come up with to solve these problems, if I want to rewrite both these fractions, is to figure out what my LCD is. Now if I look at my numbers, 6 and 5, I know their greatest common multiple is 30. So that should be in my LCD. I have x's in both denominators, and the highest power of x is x squared. I have y's in both of my denominators, and the highest power of y is y to the third. This is what I need to rewrite each fraction to have. So if I look at the first fraction, 11 over 6x squared y squared, I need to figure out what is this fraction if the denominator was this. Does this look familiar as to what you did earlier on in these problems? Exactly. I'm looking for what this number should be. So, what can I multiply this by to get this? Well, I need to multiply it by the 6 times 5. I already have the x squares, so that's fine. I have 2 y's over here, but only 1 y over there. So it seems like 5y is what I need to multiply my numerator by. If I multiply by numerator by 5y, I'm going to get 55y. So this is the first fraction written with the LCD. Now I need to look at the second one. Second one is 4 over 5xy cubed. What is this fraction written with the common denominator? 30x squared y cubed. Well, let's see what I multiply the denominator by to get the new denominator. 5 to get 30, I need to multiply by 6. I have an x here and an x squared here, so I need another x. Y cubed and y cubed, so I don't worry about the y's. So that means I multiply the top by 6x. This becomes 24x. Right here, what I have circled, this and this, are the two fractions with common denominators. Alright, last problem. In this problem, we are still trying to rewrite each group of fractions with their LCD. So that means I need to figure out between these two denominators what is the LCD. Remember, this must be done by factoring and by multiplying, not adding or subtracting. So I need to look at my denominators in factored form. In this denominator I can factor out a 2, and this denominator has y plus 2, y minus 2, because it's a dose rule. Now I need to look at the LCD. Remember, the LCD is the product of the highest power of each factor. So if I look here, I have a 2. Do I have a higher power of 2 anywhere? No. So that's in my denominator. Here I have a y minus 2. This also has a y minus 2. What's the highest power of y minus 2 that I see? Just to the first power. That takes care of this denominator, but this one here has an extra factor, y plus 2. So that needs to be included. This whole thing right here is my LCD. Now I need to go about rewriting my fractions to have this denominator. So let's look at the first one. 3y, and I'm going to write the denominator in its factored form. What must I do to the top and bottom to get this denominator? Well, it seems like these two denominators are almost exactly alike except for the factor y plus 2. So I'm going to multiply top and bottom by y plus 2. So this becomes 3y, y plus 2. That's one of them. Now let's try the other one. The other fraction, if I go back up to the beginning, was 1 over y plus 2, y minus 2. I need to figure out what that fraction would be with our LCD right here. 2, y minus 2, y plus 2. So what does this denominator have that this one does not? And what can I multiply by so I can get that factor to come up? Well, both of these denominators have the factors y plus 2, y minus 2. So the only thing missing here is just the 2. I'm going to multiply by 2 to the top and bottom and just have 2 on top for that one. These are the two answers we're looking for that I have circled.